recording. Okay, good morning, everybody.
Good morning.
You train the homework?
Yes.
All right, and then we need to do the presentation, okay? Before do the presentation, do you have any questions to ask? Or you may ask on the presentation too. Which one is better for all of you? Well, if you don't have any questions so far, so why don't we start the presentation? Or anybody want to ask questions before we do the presentation?
Yes, teacher, I want to ask.
Okay,
Esther. My question is, we have the three methods to know whether it is non-stationary, but at the second method, autocorrelation function. In this part, I don't know how to know this whether it is non-stationary.
Okay, you mean parallelograms. The second method is using parallelograms, okay? And actually, we can, okay, let me show you something, okay? Let me show you what I have done in the class. Okay, which one? So did I do this example? Yes. All right. This is the example I showed you last time, right? And so it's this one, right? LNEX. All right, if I wanted to do the parallelograms of LNEX, then I will working with this function like a parallelogram. Okay, then we are working with the levels, and we need to decide the legs. Okay, and usually I think I said that's according to the data, that's 1/4 or 1/3 of the observation of the data. But actually, if you have so huge samples, maybe you can just take a look at the first 30. Okay, so here I can choose 30. Okay, then I hit OK. Okay, this is actually the parallelograms. Okay, parallelograms of LN EX. Okay, and this one, did you see this? This is called autocorrelation coefficient. Okay, if they are highly correlated, the number of the autocorrelation, we know the range of the autocorrelation is -1 to +1. Okay, and look at those numbers. Up to the leg of 30, the autocorrelation is almost close to 95%, means 0.95, right? So if we see the range 0.95 is pretty close to 1. So they are highly correlated. Okay, we just look at the correlation of all the observations, the legs. All right. So if we see this one, means they are really autocorrelation. I mean, the observation are autocorrelation. So do I answer your question, Esther?
Yes, but I look the homework and my data results let me difficult to find whether it is non-stationary, I think.
Okay, if you see the numbers, which is pretty close to zero, means there is no autocorrelation. If this
Yes.
numbers is close to zero, means there is no autocorrelations. Okay?
Okay.
All right.
Thank you, teacher.
Okay.
Professor, so that is non-stationary, right?
Well, when we say stationary or non-stationary, okay, and when it is non-stationary, okay, means that some correlations, since we see the time series data, right? So we already see the relationship. If we just look at one variables, means that we're looking at the relationship between those observations, and it really times matters. Okay, so if they do have highly autocorrelation coefficient, means they are non-stationary. Okay, if they have a highly autocorrelation numbers coefficient, then they are non-stationary. Do I make it clear?
Yes,
Yes,
perfect,
ma'am.
Professor.
Okay, all right. So let me go back. Any other questions?
Professor, I want to ask, if the observation 30 observation, and then some of the observation like 20 observation close by 1 and then 10 close by 0, isn't it, this is stationary or this is autocorrelation or not?
You mean for the first 20?
No. Yeah, first no. They make like separate. No,
Okay,
yeah. But we
all right.
call the
That means that after some lags,
yeah.
there's no autocorrelations by themselves. But the first maybe 20 lags, they have highly correlated. Then up to some lags, the autocorrelation disappeared.
Okay, bro. Understand. Thank you, bro.
Okay.
Okay, bro.
So actually, we just look at autocorrelation numbers. If the numbers is pretty close to, usually they will smoothly reduce the number of autocorrelation started from, you can see the first lag is 0.998. They started to decline, but very slowly. Okay, then even for this example, even up to the 30 lags, their correlation still have 0.95. So it is really highly correlated. So if you see your data, maybe from the first 1 to 10, maybe, okay? And it declines, that declines up to 10, the lag of 10, and then after that, it turned out to be pretty close to 0. Means that there's some autocorrelation for the first 10 lags. Then after that, the autocorrelation disappeared. So they do have some autocorrelation for up to certain legs, but none after that. Okay?
Okay, bro.
All right. Any other questions? Okay, if you don't have any other questions, let's go back to our presentation, okay? All right, I think we'll start it from the PhD student first, okay? So let's start with Gloria.
Yes, I think, does anyone see my PPT? My slide, my sharing?
Yes, yes.
Okay, thank you. So that's my study. For the first question, I do use three method to identify if it is non-story or not. I found the graphically test, so I see the trend is gradually increase. So I think it is non-stationary. From the autocorrelation, we see the number just as Professor said before, it's a highly autocorrelation. So the coefficient number is very high, and at some point it disappear. So I think it is not stationary. So I applied the uniroot test by e-views. I saw the probably p number is 0.2, is much higher than 0.5. So it is, I'll consider it is non-stationary. Second is C. So again, from the graphic test, it is, we can tell it is non-stationary. On the PC part, it is again similar. And when I use the daily flow test, it is the probability is 0.5, is much higher than 0.5. So I consider it is, we have to reject null hypothesis as the uniroot. So it is still non-stationary. About the PT, the same situation in from the graphic test and the AC test as well. And I doing the sticky flow test. The probability is 0.07, is slightly higher. So I still reject the null hypothesis of a new root. And the last part is YD. It is non-stationary from the graphically and correlation similar situation. And a Dickey flow test is still 0.39. So it is much higher than 0.05. So still I will reject the null hypothesis of a uniroot. So that's all my study. Thank you.
Okay, all right. So next one is Eileen, right?
I'm Tove, bro.
Oh, which one is, let me see. Let me see. Let me see my name list, okay? Oh, so it is Andy.
Yes. Similar my screen. See my screen?
Yes.
Morning, Professor. I'm different with what? Gloria, because in the theory, not like.
Well,
Yes.
excuse me, Andy.
Yes.
Do you start your presentation?
Yes.
Have you started with your presentation?
Yeah.
Okay.
You show my
Well, the sound is not clear. I mean, your voice is not clear.
Maybe you just turn too loud your computer, maybe. So
Hold
you
on.
interface with your microphone and your earphone, I think.
How like this?
Perfect.
Perfect. Thank you. Morning, Professor. This is my homework assessment 5. I'm not doing
Okay, it's very
the
good. Okay, very good. Now the voice is very good. Okay, go on, go on.
okay. I'm not doing the make the grade and autocorrelation because the theory only said run 5% dipolar. This is why I'm just run dipolar. All of them, the five variable, the four variable, Y, PC, PB, and YD. This is the all of them is non-stationary because all the variable t statistic lower than critic value 5%, and the probability higher than 0.05. And then I make this one, just make conclusion downstairs. This one, you see, variable Y, the statistic 0.1508, and the critic value 5% minus negative 2.97, probability 0.9, and alpha 0.05 is mean non-stationary. And then for variable PC, negative 1.71649, and the critic value 5%, negative 2.971853, probability 0.4124, and alpha still same, 0.05, non-stationary. Also with the variable PB, the t-statistic minus 1.509099011, critic value negative 2976263, probability 0.5139, alpha 0.05 is mean non-stationary. And then the last one, variable YD, the statistic 2.138149, and then the critic value the negative 2.971853, probability 0.9998, alpha 0.05 non-centenary. Professor, I want to ask this one, the critic value, the total of the observation same, but why this one different? Negative 2.971853, and then negative 2.9756263. This one, Professor. Thank you very much.
Okay, okay. First of all, Andy,
Yes.
you have to show every variables
Okay.
Dickey Fuller test.
Okay. So this one for
Okay,
variable, yeah. This one for variable
okay.
Y. Yeah.
Okay,
This
okay.
statistic.
Okay, okay. Look at
Yeah.
the first one. Y. Okay, the
Yeah.
variable Y. Okay.
Yeah.
We'll see that all this is what we call tau test instead of regular t-test. Okay,
Yeah.
this is the first one. Okay, then the critical values. Okay, look at them. If you have the textbook, okay, would you please turn to the page of 400?
Yeah.
Let me see. Okay, look at the table 12.1. Okay, this is called 5% one-sided critical values for Dickey Fuller test.
Yeah.
All right. And the first column is sample size. The second column is the version of 12.28. We have three versions, right? The third column is the equation 12.29. The other one, which it didn't show in the on this table, is 12.27. Therefore, with the same sample size, but different version of Dickey-Fuller test,
Yeah.
then the critical value will be different.
Oh, I see. Yeah, yeah.
Do you understand what I'm saying?
Yeah, bro. Yeah. Understand, bro. Okay, I'm listening.
Okay.
Okay.
And the version of you're using, okay, like for example, the Y, which version are you using?
This one? Why?
For Y variables, which version do you use?
What mean?
How do we tell the difference with three versions?
I'm used 5%, bro.
If we're using 12.27, means what?
Different.
Means the one you just show it, exogenous variables constant. Okay, no, exogenous variables constant means you are just using the constant. Okay, so which is 12.28. Do not move your screen, okay?
No. Okay.
Why? I like to see this. Yeah.
Yeah.
This is Y variable, right?
Yeah.
Did you see the column?
Yeah.
Which is very top. Did you see the exogenous and say constant?
Yes.
Did
bro.
you see this one?
This one?
Yeah, this one.
Yeah.
This one means you have using the version of 12.28,
Oh.
which you do have constant. Constant means the constant terms.
Yeah.
Okay? And you also use the lag.
Yeah.
Which is lag 1.
Yeah.
So means this is augmented Dickey-Fuller test with the version 12.28. Understand what I'm saying?
Yeah, bro.
Okay. So according to 5%, the critical value is negative 2.97 something.
Yes.
Okay. Let me see the other variables.
This one variable PC.
Okay, this is PC, right?
Yes.
This is PC. Then you're using the same versions.
Yeah.
Okay, 5%. So do you have the same? How many observations do we have this one? I think we do have the same observations, right?
Yeah.
So the critical value, let me see. Are the two critical value same?
Different, bro.
2.97. Yeah, they
a little bit different. This one for variable Y, 6263. This one.
2.97. Let me see the Y variable.
This one, different this one. The last, the 4-digit last.
So the critical value is different.
Yes. This one for variable E.
Okay, let me see the the other one, PB or, okay, PB.
This is PB.
Yeah.
PB like
okay,
Y.
They're still using the different. There's a little bit different with the critical value, right?
Yeah. But same
But
critical value with the Y.
But they do have the same observations, right?
Yes.
Yeah, I didn't notice this one before. Okay, let me see the
Yeah, YD.
YD.
YD
Okay,
same like
you're all using 12.28, right?
yeah.
So this one is the same as the previous one, right?
Yeah.
This 2 point. Okay, let me see your summary table.
This one, Prof.
Yeah. Okay. So you have PC and YD with the same critical value, right? But Y
No,
and PB
Y
are
and
the same.
PB, Y and
Right.
PB same critical value. PC and
Yeah.
YD is same critical value.
So let's go back
Yeah.
to see the sample size of each one of the variables.
This one?
Do they have the same observations?
I checked before they have same observation but different only their critical value.
But how come they do have different?
This,
Okay, let me
yeah.
check with this one. Okay. Oh, let me see. Oh, okay. Let me see my data first. Okay, just a second. All right. Hmm. Okay. They all have 30 observations. They do have 30 observations. Let's see. Okay, let's see the Andy.
Yes, Prof.
Andy.
Yes, Prof.
Do you all use the lag is 1?
Yeah, all I
Use
use like one. Because I check
all
one
of
and all of the variable use like one.
you just use 1, right?
Yes.
Yeah. So how come we have 2 different critical values?
Yeah, this way, Prof. I asked why different because same
Yeah,
observation,
we
same
should
leg.
have.
Should I have
Yeah, we should have.
same?
And since you're using the same equations 12.28, then now according to let's see your summary table first. Okay.
This one, Prof.
Okay, it seems that Y and PB, they do Y and PB have the same critical value,
Yes.
and PC and YD
Same.
has have the same critical value.
Yes, Prof.
Okay, let me I didn't notice this question before. Okay, and Andy, you really asked a good questions. Okay, I like to check it out. Okay, and
Yes.
maybe I'll answer all of you next time. Okay, this, and I really I didn't notice this this situation before.
I'm so
Okay,
sorry, Prof.
very
Just
good.
asking, Prof. Nothing meaning, Prof.
Yeah, but
Yeah.
according to your result, all is non-stationary. That's
Yes.
correct.
Yeah.
Okay, then I go back and check the answer. Okay.
I close this one.
All right. Thank you, Andy. Thank you,
Thank
Andy.
you, Prof.
Okay. Then how about Eileen?
Can you see it, Rob? Can the class see?
All right.
Is it shown on the screen,
Yeah,
Professor? Yeah.
Yes.
So for exercise 6, using the Dickey-Fuller test, null hypothesis is variable is non-stationary, and the alternate hypothesis is variable is stationary. If the test statistic is less than the critical value, we reject the null hypothesis. If test statistic is greater than the critical value, do not reject the null hypothesis. For the YT variable, also use the Dickey-Fuller test. The statistic is greater than the critical value, so we do not reject the null hypothesis and say that the variable y is non-stationary.
Okay.
For variable PC, t statistic value of negative 1.716 is also greater than the critical value, so it's also non-stationary. For variable PB, same. The statistic value is greater than the critical value at 5%, so non-stationary. For variable YD, the statistic is also greater than the critical value, so non-stationary. That's all, Professor and classmates.
All right. So your exactly is the same as Andy's.
Yes. And
Okay.
Mr.
All right. All right. Okay. Then Moody. Thank you. Thank you, Eileen.
Thank
Then
you.
Moody.
Yes, Prof. Yes, Prof. Yeah. So, minute, Prof.
Show your screen first.
Yes,
Moody.
Prof. Minute, Prof. Still progress. Not respond. Not respond. Oh, bisa ya? Kok not respond ya dia?
Open dulu udah.
Udah.
Mana dia? Ini open dulu. Ya udah.
Komputernya nih ngaco.
Udah. Ya udah, kelihatan.
Udah.
Okay. Okay. I see the screen. Would you please make it larger?
Yes, Prof.
Bisa dulu.
Udah.
Belum. Lagi. Ya udah.
A little more.
Lagi dulu.
Okay. Okay. Thank you.
Okay. Thank you, Prof. This is my homework. I try to use Yeah, I try to use graph with y. This graph on the graph y above on the is a stationary trend, and then when I use the cologram, I see the autocorrelation is 1 until 12 is getting to closer to 0, which means its correlation is low. So this is an indication of stationary. And then when I use the
Excuse me.
yes,
Let's see the parallelogram. Okay.
yeah, yes,
So it's from 0.9, then
yeah, 0.
gradually decline to 0.8, 0.7, 0.6, then up to leg 10 is pretty close to 0.
Yes,
Okay.
well, yes.
Okay. So how do you say this, the relationship?
It means the indication of stationary, bro, because close to 0.
Yes.
It's okay, bro.
So it's an indication of non-stationary,
Stationary, bro, because close to 0, right?
but it will up to the 10th leg.
Yes, after. Oh, after the 10.
Okay, go on. Let's see the rest of the test.
Yes. The rest of the test, when based on result about using a ADF test with LS
Let me
like
see the
this.
output. Let me see the output first.
Okay.
Okay.
I use equation constant linear trend at 12.29, and the ADF less than 5% and probability 2, so I can reject hypothesis null and reject hypothesis alternative.
Okay, would you please stop here for a while? Please don't
Okay.
move the screen. Okay,
Okay.
please don't move the screen. Okay, I like to use this example, okay, to show all of you at the same time. Okay, and you all look at the output. Did you see the very top of this page? Did you see the exogenous? It shows constant and linear trend. So this means which version do we use for the Dickey-Fuller test?
Third one.
The third one. So which is the equation 12.29. Okay?
Yes.
This is 12.20. So this is the different version of what Andy and Eileen do, right? Therefore, with the same 5% critical value, with 5% level, and we do have different critical value. Well, look at this critical value is different from the one like Andy or Eileen do. They're using the 12.20, the second version. You all see that? All right. Then according to the result of this one. So Moody.
Yes, yes, bro.
Go on your presentation, okay?
Okay. Based on the result, I with ADF with LS lag result, Y with coefficient minus 0.41678. The statistic is minus 2.84811, and probability 0.0087. However, when we compare exogenous constant linear trend in 12.29 ADF, the statistic is minus 2.848110, less than critical value 5%. Besides that, the probability value is 0.1933, more than 5%. It means that the Y is unirule is non-stationary at the level data. We cannot reject its null and reject its alternative. And
Okay, stop. Okay, stop here for a while. Stop here for a while. Okay, the result according to the Dickey-Fuller test, and you are not able to reject the null hypothesis, right?
Yeah.
So means what?
Means it's the non-stationary.
Yeah, they really have unirule test. They really have the uniroots, right?
Yes.
So go back and look at the parallelogram.
Yes.
What's the result do you see from this parallelogram?
Yeah, stationary properties, different indication. That's why I want what question with you, bro? Why is different indication about parallelogram and
Well, move to your parallelogram first.
yes, yes,
Move back this one. Okay, your autocorrelation numbers is gradually decline.
yes,
Okay,
yes,
although it's still not that slow. So up to the 10th lags,
yes,
this is no autocorrelation, but still the first 9 lags are autocorrelations. So
yes.
yeah, you are not able to conclude this is stationary. If it is stationary, means that from the first to the second leg, it's already dropped it to 0.
Okay.
So according to yours, it is not automatically drop from the first to the second. It will last for about 9 legs. Then up to the 10 legs, it's turned to the autocorrelation is turned to close to 0. So with this parallelogram, this is non-stationary.
Okay. Okay, thank you, bro.
Okay?
Bro, okay, once more, bro. When I see the graph, the stationary trend. How about this, bro? The graph?
This is trend up, right?
Yes.
This is trend up. There's suspicion of the autocorrelation. So based on the graph, why? Did you see the graph like this one is the stationary? We say this is a trend up, means
Yes.
stochastic trend. This is not stationary trend.
Oh, not stationary. Okay, okay.
This is
Okay.
trend up. Okay?
Okay, bro. Thank you, bro.
All right, let's see the rest of the variables.
Okay, and VC,
Okay.
I still is based on the graph. I indication this non-stationary.
Okay.
And then the auto correlation or collabogram in the like 5 is declared close to 0.
Yeah. Okay.
And I still is assumption is correlation is low, so this is indication of stationary. And the ADF, exogenous constant linear trend, still this statistic still less than test critical value with 5%. This means we cannot reject each null and reject each alternative, and the unit root is non-stationary at the level data.
Okay. All right. Go on.
Okay. And PV graph, I indication is a stationary trend, maybe it's wrong. And then the cologram, when 11 like is declared is close to 0, it's same indication of stationary. Or if I learn from your answer is non-stationary.
Yeah.
Non-stationary. Okay, and then ADF still less than 5% level, and probability is not significant. This means we cannot reject its null and reject its alternative. PV is unit root and non-stationary at level data. And the last YD, the graphic, I still indication stationary trend, stationary uptrend. This mean maybe it's non-stationary. And when we see the cologram in the 10 leg still 10 leg is indication close to 0, but 1 until 9 is close to 1, so indication of non-stationary. And then the augmented decouple test still t-statistic less than 5%. This means we cannot reject its null and reject its alternative.
Yeah.
Okay.
Okay.
Thank you, bro.
All right. All right. Okay. And okay, let's stop here for a while. Then we'll come back. 11 and 10. Okay. All right. It's about the time. Let me stop the recording first.